Hi, everybody. So welcome back. What we're going to be talking about today is least common multiple. So least common multiple is also referred to as LCM. So we are going to be looking at two numbers. We're going to be looking at 6 and 8. So least common multiple is asking for the first number that both of these share when I multiply it out in sequence. So there's two ways you can do it. The first way that we're going to talk about is skip counting. So skip counting just means that I'm going to multiply this number repeatedly. So I recommend to go out 5 times for each number, compare, and then you can proceed further if you need to with one or the other. So I'm going to start with my 6. So I'm going to multiply 6 out 5 times. So 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4, 24. 6 times 5 is 30. Now I'm going to look at the 8, and I'm going to multiply it out 5 times. 8 times 1, 8. 8 times 2, 16. 8 times 3, 24. 8 times 4, 32. And 8 times 5 is 40. Now, if we look at what we're actually looking for, we're looking for the least or the smallest number that's in common when I multiply it out. So the least common multiple, the smallest number they both share when multiplying it out. So I'm going to start on the left-hand side because I want the smallest number. So I'm going to look at the 6 and see if there's a 6 down here. There's not, so I'm going to move on. 12, no 12. 18, no. 24 is up here and down here. So this is going to be our least common multiple. So sometimes you will have to go out for quite a while to be able to find a least common multiple. And that's why the second option for finding a least common multiple is personally my preference, but it can be a little more confusing. And that's called prime factorization trees. So we're going to use the same exact numbers, and we are going to compare them using prime factorizations. So I'm going to start with 6, and I want to start with 8. So using prime factorization trees, I'm going to be breaking up each of these composite numbers into all prime numbers that I'm going to multiply together to get this. I have to ask myself, what are 2 numbers I can multiply together to get to 6? Those are our factors. But my goal is to get all prime numbers. The only 2 numbers that I can multiply together are 1 and 6 or 2 and 3. 1 and 6 doesn't help me because it's still 6. So I'm going to use the 2 and 3. Then I need to ask myself, are either of these prime? In this case, they're both prime, so I'm going to circle both. And because both of my lines end in circles, I know I'm done. So I'm going to rewrite this as a multiplication problem. 2 times 3. I'm now going to do the same thing with the 8. And 2 numbers I can multiply together to get to 8. You have 1 and 8 or 2 and 4. The 1 and 8 doesn't help us. We never want to use a 1 when we're doing the prime factorization trees. So our only option is 2 and 4. Now I ask myself, are either of those numbers prime? And remember, for them to be prime, the only 2 factors it has is 1 in itself. And composite means it has more than one factor pair. So 1 in itself plus additional factors. So there's 1 composite and 1 prime number in this set. The 2 is prime, so I'm going to circle it, and the 4 is composite. Since the 4 is composite, I'm going to break it down again into prime numbers. So what are 2 numbers I can multiply together to get to 4? And it's going to be 2 and 2. I'm going to circle both since they're both prime. And so my multiplication problem is 2 times 2 times 2. We do want to order them from least to greatest. So what our next step is going to be is we are going to take both of these multiplication problems and we're going to stack them on top of each other. I personally like to put the one with the most amount of digits. So this has 3 numbers. This only has 2. The one with the 3 is going to go on top. So 2 times 2 times 2. Then I'm going to look down here and do 2 times 3. So what we're going to be looking for least common multiple, I am looking horizontally. I am trying to find the row with the most numbers of each digit. So I'm going to start with a 2. There are 3 2s in this line and 1 2 in this line. That means this has more of the digit 2. So I'm going to take all 3 of them. I no longer need that 2 because it's been outnumbered. It's been outranked. So that 2 goes away. Now I have a 3. I have no 3s up here, so I have to use this 3. I'm going to circle this. Now, any number that I have circled is going to be part of my multiplication problem. 2 times 2 times 2 times 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So that means our least common multiple is 24. That's the same answer that we got when we were doing skip counting. So it works either way. So you can pick either way unless your teacher specifically tells you to do one way or the other. So we're going to do one more example of both just so we can work through the process again. And so if you have any other questions, you can let me know in the comments and I'd be more than happy to help answer. So we are going to look at the number 12 and the number 20. Actually, I'm going to change that. We're going to look at 10 and 12. So we're going to first start with skip counting. So if you remember, skip counting, we're just going to repeat out the multiplication problem over and over again. And if you want to pause this to be able to see if you can get the same thing I do, I would encourage that. And then you can compare your answers with me in just a minute. So 10 times 1, 10. 10 times 2, 20, 30, 40, 50. Remember I say go out 5 times and then we can stop and compare. I'm going to do the same thing with 12. So 12, 24, 36, 48, 60. So now I'm going to look at my list and see if I have anything in common. So I have no 10, no 20, no 30, no 40, and no 50. That means I need to keep going. So I'm going to continue going with the 10s because this number is smaller than the 60. So I'm going to go out 5 more times. So 50, 60, 70, 80, 90, 100. Just to verify, I'm going to double check to see if I have any pairs at this point. And I do actually have a pair now. So both of the lines have a 60. So that means my least common multiple is going to be 60. Let's see if we get the same answer by doing prime factorization trees. So we're going to start with 10 and 12. So 2 numbers I can multiply together to get to 10. You actually only have one option, and it's 2 and 5. 2 we already determined it is prime. 5 is actually prime too, so we're going to circle that as well. So my multiplication problem for 10 is 2 times 5. Now I'm going to look at 12. You have a couple different options, and it does not matter which one you pick. So you can either pick 2 and 6, or you can pick 3 and 4. Your answer at the end will be the exact same. So let's start with 2 and 6. I'm going to ask myself, are either of those prime? We've already established 2 is prime, so I'm going to circle 2. 6 is composite, so I'm going to continue to work with the 6. So 6 is 2 and 3. Both of those numbers are prime, so I'm going to circle them. And I'm going to now write it as a multiplication problem. 2 times 2 times 3. Now I'm going to stack them on top of each other. The one with the most amount of digits on top. So 2 times 2 times 3, 2 times 5. I'm now going to compare those numbers horizontally. So I'm looking for the most amount of each digit. So I'm looking at 2s first. I have 2 2s here, and I have 1 2 here. So I'm going to pick the 2 2s. I'm going to eliminate the 1 2. It's no longer valid for us. Then I only have 1 3, and I have 1 5. So I need to take both. I'm going to take a 3, and I'm going to take the 5. Anything inside the circle is now going to be part of our multiplication problem. 2 times 2 times 3 times 5. So now when I multiply it out, I should get my answer. 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. So we did get the same answer as we got when we were skip counting. I hope you guys learned a lot from this video. If you guys have any questions, please leave me a comment. Please like the video and subscribe to the page so you can get more content when I release it. Have a great day. Bye.